Hello there, Algebra 3 students. I'm responding now to several of your homework questions on the assignment from Chapter 16, Section 2, which was the assignment that I had asked you to turn in yesterday, assignment 56. So I just want to give you a little bit of guidance as far as how to do them. For these problems, I'd like you to give another go at it just to make yourself know that you can do these things, and just so that you have a little guidance. I'll get you started on the problems, but then if you still have questions, please let me know. You can go ahead and even fill that form out again for that assignment number. I think that'll be the most efficient way of me finding out if you still have things that you need to ask me rather than email. I think that'll keep it a lot more organized for me and for you. So the first question that was asked specifically on the homework was how to do questions like number 23 and 25, and they had to do with where you've got a couple of latitude numbers and you need to find out the distance between places. So for example, number 23 said that New York was at 41 degrees. There we go. I'm having a little technical difficulty here. New York was at 41 degrees and that Peru was at 12 degrees. Okay. So what that means is that the difference of those two is going to give you your final number of degrees to use in this formula. And then, of course, you need to change your degrees to radians. So once you have done this problem, let's see, 41 minus 12, we get, like I say, a little bit of technical difficulties here because I'm trying to project this on my TV to save my neck. So 29 degrees, and then you would multiply that times pi over 180. And then once you made that into radians, because remember you have to use radians on this, you would use the radius of the Earth, 6,400 kilometers, and you would plug that in, you would get your number, and that would be for number 23. You would be able to then find the distance between New York City and Lima, Peru. The same thing basically for 25 as far as guidance, except that you are given the value for S first. You're given the 1,200 kilometers apart for Madison and Dallas. So you would put 1,200 into this spot right here. And then when you solve for theta, you know the radius of the Earth is this. You would solve for theta. It would give you your answer in radians. And then after you got your answer in radians, you would convert that to degrees. But what you need to do is you need to then figure out whatever number that is, and then you need to add it to the 33 degree. Add it to the 33 degrees to figure out how far it is from Dallas. Remember, Texas is south and South Dakota is more north. So you would have to add whatever number you get in degrees to the 33 degrees, which is where Dallas is, in order to find out where Madison is. Number 27 deals with two gears, and it says the smaller gear drives the larger one, and the smaller gear goes through a radius of 300 degrees. And since it goes through 300 degrees, what you would need to do is you need to make that into, once again, into radians by multiplying by pi over 180. We're using this formula once again, but since you're given that there is a 3.7 centimeter radius, you would plug in the 3.7 here, your number of the angle measurement in radians here, find out S, but then once you find out S, whatever number that turns out to be, you would then redo the problem and use the 7.1 radius from the larger gear, whatever you got for S, then solve for theta, which would give you your area, your angle in radians, but then in order to make your radians into degrees, remember radians degrees is to take 180 degrees divided by pi. And once you've got your 180 divided by pi, that's when you would be able to actually multiply that by the new answer you got, and that would give you your number of degrees for the larger one. All these problems really have to do with either the distance formula, in other words, the formula along the edge of a curve, or the area formula. Question 33, one of you asked about how many inches will the weight in the figure rise if the pulley is rotated through an angle of 71 degrees 50 minutes. 50 minutes. So don't forget to get the decimal form. You would take 71 plus 50 over 60. That would give you your decimal form in degrees, but then you'd need to multiply that by pi over 180 before you use it in the formula. You'll use that in the formula S equals R theta, and your radius is given in the picture on that one. And that would tell you how many inches that it would pull up. Okay, part B, they give you the number of inches pulled up, which would be S. The radius is still that same 9.27 inches, and that will give you theta in radians. And in order to change the radians into degrees, you'd multiply that number by 180 degrees. It does say to give the answer to the nearest minute, but you can just go ahead and give a decimal with the degrees, and that's fine. And then the next jump to the questions was some people had some questions about 45, 47, and 49. They all are asking you to find the area of a sector. So our area formula is right here. Each one of them gives you a radius, and each one of them gives you a value of theta. Some of them are given in radians. If it's in radians, it's a matter of plugging in your answer and using your calculator to solve it when you're given R and theta. Number 49, however, is a little bit trickier because it has your number of degrees for your angle rather than radians, so you have to take your 81 degrees. I'll go ahead and follow through number 49 in its entirety. 81 degrees, and you're going to change that into radians by doing pi over 180. I'm just going to go ahead and use the calculator on that one. And with the calculator on that one, I'll take 81 times pi and then divide it by 180. So we are at about 1.414, about 1.414 radians. And then when I plug that into area equals 1/2 r squared. R, they said in this problem, is 12.7. And then times are 1.414. So once again, we're going to divert to the calculator. You can do 1 divided by 2 for a half, or you can just do 0.5 times 12.7 squared. Oops, 12.7. Unfortunately, it missed the 1. 12.7 squared times 1.414. And again, now I doubled this. Let me delete that. There you go. And so we get that the area of this is about 114. I believe it says to the nearest tenth, so 114.0. Centimeters squared. So that's really all there is to doing those. Okay, and putting the numbers in and getting an answer. Number 55, I believe, was the next one that somebody had an answer, a question for, and number 55 actually has you doing absolutely everything, because it's talking about, it says there's a medicine wheel apparently with Native Americans make these up, and they said that there's 27 spokes in the wheel, so divided up into 27 different pieces in there, which means that the central angle in degrees for part A, you would have to take the number of 360 and divide it by 27. So we'll take 360 divided by 27, and you get about 13.3. And it did say to find that in degrees and radians, so you would take the degrees and you would change it into radians by multiplying by pi over 180. Once you have that in radians, it gives you in part B the radius of the wheel. So you would take that and you would use our S formula, or no, actually without even the S formula, you would use circumference equals 2 pi r for part B. So 2 pi r for the circumference, and that would give you the radius of the wheel. It says find the length of each arc intersected by the consecutive pairs of spokes. So if you find the circumference, you could divide that up by the 27 and then find the area of each sector by using the area formula. Or you could, the other way you could do part C would be to use this formula, S equals R theta, where you're using the radius that's given and the theta you found for the, you could find the theta from part A in radians. Okay, that would be another way to do part C. Part D would be to take this formula. Your theta would be in radians, the radian measure that you found in part A, and your radius would be the radius that's given. So that would be your basic rundown as far as how to do question 55. And I think I've got you going on that. The other questions that were asked had to do with, somebody had asked, could I please explain more about the 30, 60, 90 triangle that's used in here. Now, in our 30, 60, 90 triangle, what you've got here is, remember the proportions for any 30, 60, 90 triangle. Let me see if I can get a good triangle going here. The right triangle, here we go. In any 30, 60, 90 triangle, your proportions are 1, 2, and the square root of 3. So if you have the proportions 1, 2, and the square root of 3, and your 30 degree angle is here, what we need to keep in mind is you've got a hidden 30, 60, 90 triangle on any of them that go down to the x-axis, okay, that deal with 30 degrees. So that will be all 4 of these triangles. However, the radii on all of them are 1. I need to make my radius 1 to be able to make sense of this particular thing. So when I divide each piece by 2 on the 30, 60, 90 triangle, I get 1 for the radius, which is what we need because it's a unit circle. But then the other pieces fall into place. So for example, the x-coordinates are all going to be some form of square root 3 over 2 for all of these, because that's the x-coordinate on a 30, 60, 90 triangle. And the y-coordinates are all going to be 1/2 in these particular problems. I know I'm explaining this slightly different than yesterday, but that's good because the question was asked because it needed to be clarified. So here's just another way of thinking about it. The ones that are the 30, 60, 90s that are on their end, what you could see is the 1/2 side would be the x direction and the y direction would be on the square root of 3 over 2 side. So that's where these numbers come from in all the ones that are based off of a 60 degree reference angle that goes back to the x-axis here. And then also we have our 45, 45, 90 triangle. And we know that in a 45, 45, 90 degree triangle, our proportions are 1, 1, and the square root of 2. The problem with this is that all of our spokes here, all of our radii are 1. So this side is the one that has to be a 1. So we're going to divide all of them by the square root of 2 so that they remain proportional. However, you know how to rationalize a denominator, so these are also equal to square root of 2 over 2. So this side is square root of 2 over 2. This side is square root of 2 over 2. So that makes all of ours that are based off of 45 degrees have a square root of 2 on the x and a square root of 2 on the y. The positives and negatives, once again, go by what quadrant those things are in. So I hope that clarifies that for the person who asked about the 30, 60, 90 triangle. And the other person had wanted a little bit more on the domain. Now the domain, if you choose to go into pre-calc, you'll be dealing a lot more with domain and range. Okay, so here we are back with the domain. Now we haven't actually done graphs, so it might not be clear to you as far as, well, wait a minute, what about, how can we have a domain and a range in this? The domain doesn't really mean in this one what you might be used to, but domain, remember, is x values, so we can understand it on that level. So even though the sign of S is y, it still means that because the value of x doesn't really matter, there will always be a y to go with it, no matter what the x value is. All the way around, there will always be a y value. So the sign, meaning the domain, the x can be whatever it wants to be. Now it's not strictly just the x and y here. We're going to be looking at another type of graph in the next chapter. This may even be a little bit of a misplaced concept, but we're really looking at what these values, what values in here would mess up being able to find one of these things. So you can always find a sign value no matter where you are on the unit circle, because there will always be a value in y. So our domain is anything. Same thing with cosine. No matter where you are on this circle, and weirdly enough, our domain is more tied to the number of radians than it is to the actual x's and y's. You will always be able to find a cosine. So think about it this way for now, that we're really asking, where can we always find values? Which values for s? Where can we always find values on the unit circle for these various different trig functions? So tangent and secant, you can't find a value for this, for tangent or a secant when x is 0, because you can't have a 0 in the denominator. And the places that happens is here and here, because we're not allowed to have zeros in the denominator. So our domain is really just asking us where we can have our, what values for our number of radians, what values for our angles are allowed, and we're allowed to find values. We will find an answer for the question that's not undefined everywhere except for when we hit this spot and when we hit this spot. For cotangent and cosecant, we'll find answers anywhere except for when y gives us a 0, which will be here and here. This is kind of like a preview part of the lesson, and it will make more sense once we start doing graphing in the next chapter. So if you're just on the edge of understanding this part right now, don't worry about it too much. But I did want to address your question because you asked it. And I believe that that's going to be good for right now. And I'm going to stop, and I'll post this up so that you can have something to look at when you're doing your class and have a little feedback. Don't forget to give feedback on whatever it is that you're doing. And if you still have any questions, make sure you email me. Thanks. Have a really blessed day.